Hello everyone, my name is Eui Ko. I'm really sorry for showing video presentation. Today I will be talking about a lightweight and transparent compensation mechanism for folk cloud storage framework. Uh, let's start. Here is our overview. First of all, I will introduce the problem of our paper, and next I will propose our mechanism, which is a lightweight and transparent compensation mechanism for folk cloud storage, where I'm going to mention folk cloud storage architecture and our proposed compensation mechanism. And next, I will show analysis of the proposed system. Lastly, I will say about the conclusion. At first, introduction. Here is our basic problem. Nowadays, many researchers believe that Internet of Things, called IoT, will play a crucial role in shaping our near future due to their important applications. The majority of IoT devices are resource limited and therefore highly dependent on remote computing resources, especially cloud computing infrastructure. As the number of IoT devices are rapidly growing, it is expected that in the following years, the demand from IoT devices to the central cloud will quickly grow and exacerbate the already high latency among them, and eventually drop quality of experience of the IoT applications to an unacceptable level. In fact, in 2012, Cisco has introduced the notion of fog computing as a potential solution for this problem. The core idea of fog computing is to migrate the functionalities of central cloud to network edge close to end users so that the latency can be decreased and demand toward the cloud can be reduced. So now I will introduce our proposed scheme, which is a lightweight and transparent compensation mechanism for cloud storage. Above all, I introduce a fog cloud storage architecture. So this figure illustrates the outline of the fog cloud storage system. The framework consists of three main entities, which are end user, fog-aware SDN routers, and the central cloud storage. In this figure, the fog cloud storage environment is composed of 5 fog-aware SDN routers with regional fog storages FA, FB, FC, FD, and FE. Only 4 of them provide storage service to user, so the routing path from user to cloud becomes something like this. So user sends data to fog A storage, and fog A, it's called FA, sent to FB, FB sent to FD, FD sent to FE, finally FE sent to the cloud, like this. So if FC passes toward the data block to the next available fork router, FD, without storing any subset of messages. Suppose that the user's data storage request is managed by only fork-aware SDN routers and the central cloud does not store any subset of messages. Then the central cloud will only keep the receipt, which proves the integrity of the data. This is our proposed compensation mechanism. Once data is uploaded to the fork cloud storage, a proper compensation has to be paid within every interval for the continuity of the service. The proposed compensation scheme consists of following three distinct phases, which are compensation preparation, compensation distribution, and compensation acknowledgement. In compensation preparation, for each message block MI, here the user compute the key like this one. So here H is cryptographic hash function. So now let's consider we have the key 1 to key n. Then the user prepares an encrypted payment coupons P1 to Pn for the message blocks. After after the compensation preparation phase, the user sends the P, which is the set of the encrypted payment coupons, to the central cloud. The start from cloud, the payment coupon is distributed in the reverse order of the routers appeared in R, which is the order of routers over which the messages is delivered toward the central cloud. To make you easy to understand, show the procedure for our mechanism. This will show how our mechanism works. As you can see, first the router R1 witnesses the all messages. So of these, R1 stored the message 0 and message 1. Then router R2 can witness messages all messages except message 0 and message 1. So of the message 2 to the message 9, R2 stores M2, M3, and M4. And next, router 3 can get and witness messages from the message 5 to message 9. So among them, it stores message 5 and message 6. So R4 also witness message 7, message 8, and message 9. it stores the message 7 and message 8. Finally, the cloud router can only see the message 9. No, that means it can stores only message 9. So this procedure is shown as the data block flow. So once the message blocks are stored across the network storage clusters, the set of payment coupons is sent to cloud router. So since the cloud router stored only message 9 block, it can take only payment 9, which is corresponding to the data block. Then the rest of the payment coupons are sent to R4. Then R4 also takes P7 and P8, which are corresponding to data blocks R4 stores. In the followings, R3 takes the P5 and P6, and R2 takes P2, P3, and P4. Keep going. Eventually, R1 takes P0 and P1. So this is shown as payment coupon flow. So for our proposed system, there are 3 major merits. First of all, low computation overhead at user side. For the compensation distribution, the user needs to compute a hash value for each of n message and include a payment coupon for the message with the hash value. For the verification of acknowledgement, it needs to compute a hash chain of the n random values. As a result, the whole process requires 2n hash function computation and n symmetric encryptions. As both computations are not heavy, so the proposed system incurs low computation overhead at the user terminal device. Second, low communication overhead. In the proposed scheme, in addition to upload the n message blocks, the user needs to upload the set P of the n payment coupons and download a single hash chain value to verify the correct receipt of the payment coupons. As a result, the whole process requires only n+1 message exchanges except the upload of the n message blocks. Therefore, the proposed system causes low communication overhead. Lastly, the user uploads the message blocks toward the central cloud. Each regional fog cluster absorbs some part of blocks autonomously, and the user receives the confirmation of receipt of stored data from the cloud. On the other hand, the payment coupons go directly to the central cloud and distributed among the responsible local fog storages. During the whole process, the user only can see the cloud and interact with only the cloud. Therefore, the proposed system does not require any change on existing end-user terminal devices, as long as they are capable of interacting cloud infrastructure. So now I provide the analysis of the proposed system. We divide the proposed system into two phases. One is for compensation distribution phase, and the other is for compensation acknowledgement phase, and show the correctness analysis of each of them. Actually, for this section, I'm not going to explain in detail for proof, because there are a lot of the definition and lemma in our paper, and based on this we proved theorem 1, theorem 2, and theorem 3. So please refer our paper. Lastly, conclusion. Fog cloud storage is an emerging concept to challenge one significant limitation of the central cloud storage of the future, like high latency. In order to promote the broad adoption of the fog cloud storage concept, it is crucial to have a practical compensation scheme for the for the storage service providers. However, no such mechanism has been introduced in the literature so far. This paper introduces a transparent and efficient compensation mechanism for the fog cloud storage service providers. So our proposed scheme has some advantages. Its compensation mechanism for the network data storage service is transparent to users in a sense that any end user device which can access a cloud storage can use the payment scheme without any modification on the end user device, and does not need to know the existence of any fog storage provider. Furthermore, it results in lower computation overhead and lower communication overhead. So we also provide a rigorous analysis of the correctness of the proposed scheme in the paper. Please refer our paper. And as a future work, we plan to investigate the adoption of the blockchain technology to improve the reliability and applicability of our fog cloud storage and compensation network. So thank you so much for listening my talk.